here's the last type of graph, which is the cotangent. You'll see that the cotangent curve actually is very similar to the tangent curve. So the way that we're going to do this is that remember that the cotangent of x is equal to the cosine over the sine. So notice that here you'll have vertical asymptotes wherever sine of x is equal to 0. Okay, so let's start off by looking at the unit circle. And if you look at the unit circle, remember that we were tapping into the quadrantal angles. Sorry, my cat was doing something weird. Okay, so 0 to pi over 2, then pi, then 3 pi over 2, and then 2 pi. Okay, and then also what we also were looking at, we were also looking at the fourth, so pi over 4. So this square root of 2 over 2 is going to be really helpful because since we know that the sine over the cosine or the cosine over the sine is going to give me 1, the pi over 4 is going to be really useful. And actually in this case also the 3 pi over 4, because this will be negative square root of 2 over 2 and square root of 2 over 2. So those angles are going to be really useful. So we're going to start off with 0. So let's start by graphing. So here's my x-axis and here's my y-axis. We're going to start at 0. So starting at 0, you know that this point is associated with 1, 0. Now, because it says cosine divided by sine, notice that we're going to have 1 over 0. That's already undefined. So right off the bat, we have a vertical asymptote at 0 for the cotangent curve. Next, let's look at the pi over 4. We know that at pi over 4, we're going to have square root of 2 over 2 divided by square root of 2 over 2. That's going to give me a 1. So we have a 1 there. Then at pi over 2, we have the point 0, 1. So the cosine divided by the sine is going to give me a 0. And then finally, we're going to have this 3 pi over 4, which is essentially this guy, which is going to give me a negative 1. So that one's going to go here. And then when we go to pi, you're going to have negative 1 over 0, which is going to be negative 1 over 0. So at pi, you're going to have another vertical asymptote. So what you kind of can see is that the cotangent curve kind of looks like the tangent curve, but it's just shifted. Okay, so this is kind of what the cotangent curve looks like, and then later on you can see that this is going to continue to oscillate. So you'll have more cotangent curves over here. So it'll continue on. Cycling, okay? So one thing that you can see also is that here it's clear to see that from 0 to pi, that's just pi units. So you actually have a period of pi. So what I wrote here, and there's a mistake here that I want you to correct. This shouldn't be a pi over 2. This should be a pi. Okay, so please correct this because this is actually a really crucial mistake. So one period can be found in the interval from 0 to pi. Okay, and you can see that here. It's from 0 all the way to pi. So that's a mistake. So please correct that in your notes. So you can think about the cotangent curve as shifting pi over 2 units. So I've shifted everything pi over 2 units. And it's flipped across about the x-axis. So if you think about the tangent curve was going downward and then up. And now the cotangent curve is going from the top down to the bottom. So it's a little bit opposite. So it's kind of flipped. Okay. The period, as you can see, is still pi over absolute value of b. So it's still going to be pi. So we're using the same exact methods that we've been doing all this time, but now we're going to do it for the cotangent curve. Now, remember what the cotangent curve kind of looks like. All right, so now we're just going to go ahead and jump into some examples so that we can get used to the cotangent curves. So let's start off by graphing the following. So y equals cotangent of 3x. So notice that you have a 3 in the inside. So what we're going to do is we're going to use this interval to try to solve for the new asymptote. So here's where the asymptotes are before we do anything. And then since we have a 3x, we're going to put them in here. And then you're going to just solve for x. So divided by 3, you're going to have x is going to be between 0 and pi over 3. Okay? So now when you graph this, you can see that my first asymptote is going to be at 0, and my next asymptote is going to be at pi over 3. So now what we want to do is we want to find the midpoint. So let's figure out what this midpoint is. So pi over 3 plus 0 divided by 2, that's going to give me just, what is this, pi over 6. Okay, so the midpoint is going to be pi over 6. Now we're going to take this pi over 6 and add it to 0. And then divide it by 2. It's going to give me pi over 12. So this guy is going to be pi over 12. And then finally, we're going to look at pi over 6 and pi over 3. So pi over 6 plus pi over 3 divided by 2. So we're going to do pi over 6 plus pi over 3 divided by 2. That's going to give me pi over 4. Okay, so this guy is going to be pi over 4. Oh, no. Yeah, that's right. Pi over 4. Okay. Now, remember that the cotangent starts at 1. So pi over 12 is going to be a 1. Then it's going to be 0. And then it's going to be negative 1. Okay, and then our asymptotes are just hanging out outside. So this is what the graph will look like. Okay. Alrighty, so same thing as before. We just have a different interval now. It's going to be from 0 to pi. Alright, so now let's look at this next problem. So we have a couple of things. We have an kind of like an amplitude change, but in this case, it's just a vertical stretch. And then we also have a phase shift. Okay. So let's start off first with my interval from 0 to pi. And we're going to put in the argument inside of the x. So x minus 2 pi over 3 between 0 and pi. So we're going to add this 2 pi over 3 to all three sides. So you're going to have x by itself. 2 pi over 3 is over here. What is this going to give me? 3 over 3. That's going to be 5 pi over 3. Okay, so that's what I'm going to end up getting. All right, so that means that my asymptotes are between these two different endpoints. Okay, so I'm going to write that. So here's 2 pi over 3. Here is 5 pi over 3. Here are my equation of these asymptotes. Here are the asymptotes. And now we're going to find the middle point. So we're going to start off by writing down 2 pi over 3 plus 5 pi over 3. And we're going to divide it by 2. So this guy is going to give me 7 pi over 3 divided by 2, which gives me 7 pi over 6. So 7 pi over 6 is in the middle. Okay. And now what we're going to do, we're going to take this 2 pi over 3 with the 7 pi over 6. So 2 pi over 3 plus the 7 pi over 6 divided by 2. Okay, you can either do it using the least common denominator, or you can just put it in your calculator. So you're going to have 7 pi divided by 6, and everything's divided by 2. Okay, cool. So this is going to give me 11 pi over 6. 11 pi over 12. Okay, so this is going to be 11 pi over 12. And now the last one is going to be this guy. Okay, so between 7 pi over 6 and 5 pi over 3, I'm going to divide this by 2. Okay, so we have 5 pi over 3 added to 7 pi over 6, and we're going to divide this by 2. So we're going to get 17 pi over 12. Okay. So that's what we have. All right, now here what we can do, so we have kind of like what the x values are. Now what we really have to look at is look at the cotangent curve. Now notice here that we can kill two birds with one stone by multiplying also by this horizontal shift. By this vertical stretch. So before it was a 1, now it's going to be a 1/2. So this negative 1 is now going to be a negative 1/2. Okay, so now instead of a 1, you're going to have a 1/2, then a 0, and then a negative 1/2. So basically what it's doing is that this guy just kind of shrunk. Okay, so you kind of just squashed this cotangent curve a little bit. So it's no longer at 1, now it's going to be at 1/2. So you can kind of kill two things at the same time just by doing so. Okay. All right, so now let's do the last problem, which we have y equals -3 cotangent x plus 1. So here, we don't have anything going on in the inside, so we don't have to worry about that. We just have a multiplication of 3, a flipping of a negative, and then an addition of 1. So let's start off by writing the cotangent curve. So cotangent of x. So remember that, whoops. So remember that it starts at 0 and it ends at pi with this vertical asymptotes. The inside is going to be pi over 2, pi over 4, and then 3 pi over 4. And then remember that it starts at 1, it ends at -1. Okay, so remember its shape. So always remember the shape of the cotangent. Okay, whoa, that's so bad. Okay. So there we go, a little better. Okay. So now the first thing that we want to do is deal with this -3. Okay. So remember what's going to happen is that all of these y values are going to be multiplied by this -3. Okay. So these y values, when we multiply them by -3, so first of all, nothing's going to happen to these asymptotes. So the asymptotes stay the same. They're still undefined. That's still where it's undefined. What's going to happen is that when you look at this pi over 4, and pi over 2 and this 3 pi over 4, you're going to have a couple of things. So here, this 1, when you multiply it by -3, now it's no longer at 1, now it's at 3, but then I got to flip it. Okay, so I got to flip it down to a -3. So this guy's going to be down here. This guy, nothing happens to it, so it stays at 0. And now this -1, when I multiply it by 3, it goes down to -3, and then I flip it to a +3. So you can kind of see that this guy now kind of looks like a tangent curve, okay, because we kind of flipped it, okay. Now we're not done yet because this guy was just the blue thing, which was just the -3. Now all we got to work with is this +1, okay. So the +1, if you remember, you add 1 vertically. So you're shifting everything up by 1. So everything is going to go up by 1 unit. Okay, so now this guy before was -2, -1, 1, 2, 3, 4. So these guys are not going to change. Pi over 4, pi over 2, 3 pi over 4, and then pi. So the asymptotes are still the same. Okay, now everything is just shifted up 1 unit. So before this guy was a -3, now it's going to be a -2. This guy was at 0, now it's going to be at a 1. And then finally this guy was at a 3, now it's going to be at a 4. So this whole graph is going to look something like this. Oh God, this is really bad. Okay, sure, like this, okay? Okay, so as long as you can give me these points and the asymptotes, you should be okay. But this is basically what the graph of cotangent works, or looks like.